Welcome back. In this video, we're going to go over section 2.3, which continues our look at solving equations. What's different in this section is that where in the past we may have seen just variables on one side of the equation and constant terms on the other, in this section we may see both variable terms and constant terms on either or both sides of the equation. So let's try. Starting with this first one, we have 3x plus 4 equals -8. And remember, our goal is to end up with just x equals, and then whatever the answer is down here at the bottom. And the tools that we have at our disposal, aside from things like distributing to remove parentheses or combining like terms, are the addition, subtraction, multiplication, and division properties of equality, basically that you can add, subtract, multiply, and divide on both sides. So the questions primarily are, well, what steps should I take at any one time? So here, should I divide by 3? Should I take away 4? What should I do? If you know what to do, go for it. If not, here's how to figure out what you should do. Forget the -8 on the right side and take a look at the left side, which is 3x plus 4. Suppose that I told you that x was 1023. Okay, and I wanted you to calculate 3 times that plus 4, which you could do on paper in a calculator or in your head, I don't care. But if you were going to do that, what would you do? You would first multiply by 3, then you would add 4, right? According to order of operations. In order to figure out the steps that you would take, you reverse those steps in reverse order. So to undo the addition of 4, you'd first subtract 4. And then to undo the multiplication by 3, you would divide by 3. Okay, so that's the plan. We're going to reverse order of operations in reverse order. Let's try that once more, just with like a little problem. So I'm thinking of a number. I'm going to multiply by 2, and then I'm going to add 1. I got 25. Can you figure out my number? You could think back, well, you added 1 to get 25. You multiplied by 2, then added 1 to get 25. So if you take the 1 away, that's 24. So 2 times his number is 24. He had been thinking of 12. And you're right, it was 12. And you can check. 2 times 12 is 24, plus 1 is 25. So the thing is that to reverse my steps, you subtracted 1, then divided by 2. In general, you want to reverse order of operations in reverse order. So here, we're going to subtract 4 from both sides first. Okay, so I've taken the original equation, I've subtracted 4 on both sides. A little simplification will give me 3x is -12. Now this is a problem like we have done before. We're going to divide both sides by 3 to get x is -4. So -4 is our solution. Okay, let's try that again. So here, I was thinking of a number, I multiplied by 5, I took away 9 and got 16. So if you're thinking along, you might think, okay, well, if the last thing that I did was subtract 9 to get 16, then probably we should add 9 on both sides. That will give us 5y is 25, so that y is 5. Our solution is 5. Okay, let's try this one. This one's a little different because there are variables on both sides. In the last example and the one prior, we had one variable term and 2 constant terms. There was a variable on the left side and constant terms on both sides. What's different about this one is that there are still 3 terms, but 2 are variable terms and 1 is a constant term. So it makes most sense, since the left side has only a variable and the right side has a variable and a constant, to collect the variables on the left side and the constants on the right. So we're going to subtract 5n from both sides. So that on the left side, we'll have just a single n, and on the right side, -10. Okay, and that will do it. So it should be pretty clear here why we made this choice. And again, also, if we had chosen to add 10, for some reason, right, this wouldn't have gotten us very far, right? We would have just moved the constants to the left side. The way this was written originally, we had variable term on each side and a constant term on the right side. So let's leave the right side to the constants, make the variables be on the left. Okay, in this next example, we have again three terms. 3p minus 14 is 5p. For this one, we have two variable terms and one constant term. There's variable terms on both sides and a constant term on the left. Let's go ahead and leave the constant term on the left. And then if the left side's going to be for just numbers, constants, that means the variable terms should be on the right. If the variable terms are going to be just on the right, then the 3p that's on the left, we should eliminate it. So we're going to subtract 3p from both sides. Okay, so then on the left, 3p minus 3p is no p, and we have just negative 14. The right side, 5p minus 3p is 2p. Okay, now we have negative 14 is 2p, dividing through by 2, we'll get p is negative 7. The nice thing about this, and there are a lot of nice things, but the nice thing about this is that you can apply the addition, subtraction, multiplication, and division properties to your liking. That is, if in this problem you didn't like what I did, if you thought, well, you know, let's just move all the variables on the left and let's move the 14 on the right, then you can do that. Your work may look different, but your answer is going to look the same. So we're going to do this problem again. Okay, sorry. Let's say that you're thinking, okay, well, I don't like having the variable be on the right. I want the variable to be on the left. So I'm going to subtract 5p from both sides, which is legal. Math says that's fine. You can add or subtract anything you want as long as you do it to both sides. So I'm subtracting 5p from both sides. So now we have negative 14 minus 2p is equal to 0. And then sorry about that, Zoom crashed on me. So backing up just a hair, negative 14 minus 2p is 0. So I added 14 to both sides. Then if we divide through by negative 2, 14 divided by negative 2 gives the same negative 7. So the point for this is that you can take different steps and achieve the same results. Okay, and a lot of times there's personal preference. Some people like to not have negative coefficients. Some people like to have always the variable on the left. It's up to you as long as you don't end up moving things around forever and never finishing. Okay, so here we have 12a is equal to negative 4a plus 32. Total of 3 terms. 2 have the variable, 1 doesn't. My choice would be to say, okay, well, the right side is where the constant is, so let's leave the numbers there and make the variables be on the left. So let's do that. So we'll have 12a on the left side, negative 4a plus 32 on the right side. I want to get this negative 4a off of the right side because the right side I've decided is for numbers. So I'm going to add 4a. I have to do that on both sides. 12a plus 4a is 16a. The right side, negative 4a plus 4a is 0a, or 0. And so we have just 32. Okay, now we're going to divide both sides by 16. 32 divided by 16 is 2. Final answer is 2. Okay, so this one looks exciting. This one, there are 4 terms. 2 have the variable x and 2 have just numbers. So on this, there's a couple of decisions you need to make. You need to decide, well, do I want to work on x's first or do I want to work on numbers first? And it's totally up to you and personal preference, and you can't get this wrong. Just pick. Most people will pick working on variables first, but it doesn't matter. You can do numbers first if you want. Also, you need to decide, do you want the variables to appear on the left? You want the variable to appear on the right. A lot of times people like the left, but again, it doesn't matter. It's totally up to you. Often people like to pick this so that we end up with a positive coefficient, the number next to the x being positive. But again, it's up to you. As long as you're not dividing by 0, you're not going to go wrong, really. So I'm going to decide to work with variables first, just because usually people do. And I'm going to decide to put the variable on the left, just because usually people do. So if I've decided that the variables should be on the left, and I want to work on variables first, then this 6x that's on the right really should not be there. So I'll recopy the left side and the right side, and I'm going to subtract 6x from both sides. So then on the left side, 12x minus 6x is 6x's. And then on the right side, 6x plus negative 6x is no x's. Okay, now that I've committed to variables being on the left, it would be silly of me to subtract 2 from both sides, because I decided at the beginning that variables should be on the left and numbers should be on the right. And I'm done working with x's because there's only one term that has x's. So at this point, I need to work on numbers. So I'm going to subtract 8 from both sides. So we will have 2 minus 8 on the right side. So 6x is negative 6, and x then is negative 1. For all that, our solution just negative 1. Okay, as I'd said, if you had chosen to collect the variables on the right or work with numbers first, that would be okay. You're going to end up with different looking work, but you would have the same answer. Okay, so let's try a couple of more of these. So for this one, we've got 8w minus 5 is equal to negative 4w plus 7. So just for fun, this time I'm going to do the numbers first. And I'm going to put the numbers on the right still. Since I want the numbers on the right, this minus 5 that is on the left, I don't want it to be there. And so we're going to begin our process by adding 5 to both sides. So we'll go plus 5 on both sides. So then the left side, 8w minus 5 plus 5 is just 8w. And the right side is negative 4w plus 12. Okay, I've decided that the right side should be for numbers, so this negative 4w should not be there. So we should add 4w to both sides. Okay, the left side, combining like terms, we get 12w. The right side is just 12. And so then here, everybody knows that w has to be 1. Okay, so next up, here we've got 2a minus 2 is equal to 6a minus 18. So for this one, if we collect the variables on the left, we've got 2a on the left and 6a on the right. If you think about it, if we subtract 6a from both sides, we're going to have a negative coefficient on our a's. So some people don't like that. If you don't like that, collect the variable on the right. If you're fine with it, you can collect the variable on the left. This is one of those kind of personal preference things. Totally up to you. You can either subtract 6a from both sides or you can subtract 2a from both sides. Either way is okay. I think I will, we haven't had the variable on the right, so I'm going to take and subtract 2a from both sides. Okay, so we're subtracting 2a. I'd better do it on both sides. So 2a minus 2a on the left will leave us just the negative 2. And then on the right side, 6a minus 2a is 4a. Okay. And then now that I've decided the variable should be on the right this time, I don't want the negative 18 there any longer. So we're going to subtract 18 from both sides. So we'll have negative 20 is equal to 4a. And then dividing through by the 4, we'll get negative 5 for our a. So our solution here is just negative 5. Okay, and that will do it. I liked that equation. I thought it was pretty fun. And so I'm going to do it again, but this time I'm going to collect the variables on the left just for fun. And also let me deal with the numbers first, just to be different. But if you don't like this, skip ahead to the next equation or just quit the video altogether. No, don't quit the video. Just keep watching, but you can skip this next equation if you like. So here I'm going to subtract 6a from both sides. Okay, I've decided to subtract 6a. So this will give us negative 4a minus 2 on the left side and 18 on the right side. Then I'm going to add 2 to both sides. This will give us negative 4a on the left and 20 on the right. And so again, a is negative 5. Okay, totally up to you which way you want to do it. Okay, get the same answer. Some ways look like they're a little easier than others. Totally up to you. Okay, next one has got some fractions in it, but we're going to work on it in the exact same way as we did before. I need to decide if I want the variables on the left or right. I think I'll just have the variable be on the left this time. So 7/8 x minus 12, then negative 1/8 x minus 2. Let me add 1/8 x on both sides. Okay, I've done that. 7/8 x plus 1/8 x is 8/8 x. We still have the negative 12 on the left side. Equal sign is still in the same place. The negative 1/8 x and 1/8 x added up to 0, so that we just have negative 2 on the right side. Fortunately, 8 over 8 is just 1, so we have 1x minus 12 is negative 2. All of a sudden, that's way better. We're going to add 12 to both sides. And so we'll have x is 10, finally. Okay. All right, that does it. One with fractions. Okay, we just have a little more. We have just one more, actually, one to do with decimals in it. As with the other examples, we're going to do the same basic procedure as we had before, but this time our arithmetic has decimals, and that's really the only difference. Okay, so here we have 4 terms altogether. 2 have x's, 2 don't. We need to decide if we want to keep the x's on the left or right. Again, this is up to us. I think I'm going to put the variables be on the left and the constants on the right. Variables on the left and right. So on this one, if you want to pause the video at this point and then try it and see how you did, then that. Okay, so for this one, I want the variables to be on the left. And so this negative 1.4x that is on the right, I need to get rid of that. We're going to add 1.4x's on both sides. Okay, so then at this point, we have 2.8 plus 1.4, that is 4.2 x's on the left and a 12. The right side, there are no more x's, only a negative 9. Okay, and so now the left side is for variables. That 12 needs to be gone. So we're going to subtract 12 from both sides. So this will just give us 4.2. I'd forgotten an x in there. Sorry about that. We'll have 4.2 x's and no constant terms. The right side, negative 9 minus 12 is negative 21. And then finally, we'll have divide by our 4.2. That's negative 21 over 4.2. And that is the same as negative 21 over, how should we do this? It's most fun. This is 2 times 2.1. And let's see what else would be fun. This is negative 2.1 times 10. All right, and that gives us negative 5. All right, that was possibly the long way around for you. If you just want to do 21 divided by 4.2, using a method of your choice, do that. All right, so anyways, that's the end of that. So to sum up, we can use the addition, subtraction, multiplication, and division properties to collect variable terms on one side, number terms on the other, and then apply those 4 properties and use that to solve the equation. It's up to us typically which side we want to put the variable on and which side we want to put the number on. And so that's it. That's the end of this section. Let me know if you have any questions, and have a great day.